You've just taken control of SpaceX. At least in this hypothetical scenario, you now hold enough ownership to decide the company's direction. And your first discovery is that you didn't simply acquire a pile of rockets. You inherited a launch business, a satellite network, manufacturing facilities, software, ground stations, launch sites, contracts, and thousands of people working on different missions at the same time. Falcon 9 is flying customers and Starlink satellites. Starship is being developed for a much bigger future. Starlink is serving customers on Earth while its satellites are constantly moving overhead. Your real power is deciding where the company's resources go, which projects get funded, which leaders stay in charge, and which risks are worth taking. You're not personally pressing the launch button. You're deciding who gets to press it and what the company is trying to accomplish. Your first morning is less glamorous than you expected. There isn't one giant operation waiting for your attention. Several are moving at once. A Falcon 9 mission can be preparing on one coast, while another booster is being recovered offshore. Starlink satellites are being deployed, and Starship teams are working through another test campaign in Texas. At the same time, customers are waiting, government missions have deadlines, and consumer internet service has to keep running. That changes your job immediately. You're not managing one rocket company in the old-fashioned sense. You're overseeing launch operations, satellite communications, manufacturing, software, customer service, research, and future spacecraft development under one roof. The scale creates a strange problem. Even if you make one smart decision, dozens of others still have to happen without you. Your first challenge is building a leadership system that can handle all of that. Eventually, you ask the question every owner asks, where does the money actually come from? One major answer is Starlink, which sells satellite internet service to customers around the world, creating recurring revenue rather than waiting for individual rocket launches. Then there's launch revenue, where customers pay SpaceX to send satellites, spacecraft, and other payloads into orbit. Government work adds another stream, including NASA and national security missions. But revenue is only half the story. Money also flows straight back into the machine. Rockets, satellites, factories, launch infrastructure, software, employees, testing, and new technology. A giant revenue number doesn't automatically become money you can take home. You're constantly choosing between operating the business you already have and funding the systems that could make it much bigger later. And one of your biggest expenses is something you can watch happen from a launch pad, keeping rockets flying. A Falcon 9 launch looks almost effortless when you watch the final countdown. As the owner, you know the real operation started much earlier. Teams have to build and inspect the rocket, prepare the payload, load propellant, check weather, verify safety systems, coordinate range operations, and prepare the launch site. After liftoff, the first stage can perform its dramatic return to Earth, sometimes landing on a drone ship at sea. Then that hardware has to be recovered, inspected, refurbished, and prepared for another mission. The same cycle repeats across launch sites in Florida, California, and Texas, while customers and schedules keep moving. The advantage is reuse. A booster that flies again can support a faster launch cadence than a disposable rocket, but every delay has consequences. A weather problem, technical issue, or range conflict can push an entire chain of operations backward. Then you realize Starlink has turned SpaceX into something much bigger than a rocket company. Thousands of satellites have to work together overhead, while ground equipment, network software, customer terminals, and support systems keep the service connected on Earth. Customers don't care that their internet connection comes from space. They expect it to work like any other internet service. That means satellites have to be launched, positioned, monitored, replaced, and upgraded continuously. The network can also expand into new capabilities, including direct-to-cell connectivity that aims to connect ordinary phones through satellites. From your perspective, that creates a very different ownership problem. A rocket launch is an event. A communications network is an always-on service. You can't simply finish a mission and walk away. Every day, somewhere above Earth, hardware is moving, systems are being monitored, and customers are expecting the network to work. Starship is where your long-term ambitions become much harder to measure. Falcon 9 already gives you an operating launch system, but Starship is being developed around a much more ambitious idea, a highly reusable system capable of moving people and cargo on a far larger scale. That potential comes with enormous development work. Test flights can reveal problems that require hardware changes, software updates, new procedures, and more testing. NASA is also relying on a SpaceX lunar lander version of Starship for future Artemis missions, adding another layer of responsibility. You face a difficult choice. Keep pushing aggressively toward the future, even when development is expensive and uncertain, or put more resources into businesses already generating revenue. There's no simple spreadsheet answer. A successful Starship could change what SpaceX can do. A prolonged development struggle could consume time and money that might support other priorities. Just when you think the company is mostly about commercial customers, the government contracts start piling onto your calendar. NASA depends on SpaceX for important missions and is working with the company on lunar landing systems. The U.S. Space Force also uses SpaceX launch services for national security missions, including recent Falcon 9 launch awards. These contracts can provide opportunities, but they come with different pressure. Reliability, security, schedules, safety, and mission requirements matter enormously when the payload supports astronauts or national defense. You can't treat a government mission like a delayed online order. There are procedures, oversight, and consequences. Government work can also connect different pieces of your company: rockets, communications, spacecraft, and infrastructure. The more important those systems become, the more responsibility comes with them. You gain valuable customers, but you also inherit expectations that are extremely difficult to ignore. From the outside, SpaceX can look like rockets, launch towers, and dramatic videos. Behind those images is a huge coordination problem. Engineers design hardware while manufacturing teams build it. Suppliers provide specialized components. Technicians inspect equipment. Software teams control complicated systems. Launch crews coordinate countdowns. Regulatory teams handle approvals and safety requirements. Customer teams manage payloads and schedules. None of those groups can simply work whenever they want. One delay can affect several others. That's why your hardest decisions may have nothing to do with choosing the next rocket design. You're deciding where people, money, factories, testing time, and launch opportunities should go when everything matters. The company's advantage is speed, but speed creates pressure. Move too slowly and competitors can catch up. Move too quickly and mistakes become expensive. You're balancing both, keeping a huge machine moving without turning speed into chaos. Eventually, something goes wrong. A launch can be delayed by weather or technical problems. A booster can suffer damage. A Starship test can expose a failure that forces engineers back to the drawing board. A satellite can develop an issue after reaching orbit. A customer can change requirements, or regulators can require additional work before an operation moves forward. The hardest part isn't fixing the problem, it's absorbing the consequences. A delayed launch can affect customers, crews, hardware, schedules, and future missions. A failed test can consume development time and force changes. Yet stopping whenever something might fail would make the company less ambitious. Your job becomes a constant risk calculation. Which failures are acceptable learning experiences? Which ones are warning signs? And when should you slow down? Owning SpaceX means you don't choose whether problems happen. You choose how the organization responds when they do. So what would you actually control if SpaceX were yours? Not every launch, satellite, or engineering decision. Your real control sits higher up. You decide the company's broad direction, appoint or retain senior leadership, approve major investments, and determine how aggressively to pursue projects like Starship, Starlink expansion, and future technologies. You'd also decide how much attention goes toward commercial customers, government missions, communications, and exploration. Ownership gives you enormous influence while forcing you to rely on other people. You can own the company, but you can't personally design rockets, monitor satellites, negotiate contracts, and supervise every launch. Your job is to build the organization capable of doing those things without you. In the end, owning SpaceX wouldn't feel like owning rockets. It would feel like steering an enormous machine that never really stops moving.